The first problem looks like a polynomial equation. The way we solve those is we make them equal to 0. So just to get started, I'm going to say 3 sine squared of x minus sine of x minus 2 is equal to 0. And then we talked about replacing sine of x with y, so we could easily factor this. So 3y squared minus y minus 2 is 0. Factoring, we said you multiply the first and the last numbers together to get -6 and add up to -1. So -3 and 2 would do the job here. So we get 3y squared minus 3y plus 2y minus 2 equals 0. Factoring, you get y minus 1 and 3y plus 2. Now, if we set those equal to 0, we get y is 1 and y is -2/3. But remember, that's what sine of x is equal to. So at this point, I'm running a little low on space, but let's see if we could figure this out. The first part, when is sine 1? Well, remember your quadrantal angles, and I know sine is 1 when the angle is 90 degrees. So right here, sine is 1, and that's at 90 degrees. The problem is in radians, so you should just answer pi over 2 would be the answer for this. Right? 90 degrees gives us a sine of 1 because sine is the y value, and that's what we get. Now, the next one of -2/3, that's why I asked you to have your calculators out, because we're not going to be able to get that from a special triangle. When we went to solve trig equations, remember what we had to do is figure out the reference angle. And if sine is negative, which quadrants are we going to draw this in? Because we know all students take calculus. Which quadrants would sine be negative in? So we're not going to draw it here. We're not going to draw it here. And on your calculator, you're going to ask your calculator, what is the inverse sine in degree mode, inverse sine of -2/3? And my calculator is telling me 41.8. That's the reference angle, 41.8 degrees. So I'm going to draw 41.8 degrees in the quadrants where sine is negative. But that's not the answer because we have to actually figure out what those angles are. And the first one is going to be 180 plus 41.8, and that's 221.8. We can convert that to radians in a minute. That's this first angle. The second angle is 41.8 degrees less than 360. So 360 minus 41.8 is 318.2. The way you convert these to radians is you multiply by pi over 180. And sorry, all this is all over the place here, but 318.2 times pi divided by 180, my calculator tells me that's 5.6 radians. And 221.8 times pi divided by 180, my calculator is telling me is 3.9 radians. You should be typing those in and just making sure you're getting the same numbers. You don't want to get these wrong because you typed it in incorrectly. I'll just kind of take a minute and make sure that you guys could type these in. Make sure you have all that written down, and then we'll do the second problem. Which part? What you do is you would type 221.8 times, hit the pi button on your calculator, and then divide by 180. Pi is in the middle left, and then you just divide by 180 and hit enter, and it should be 3.9. All right, you're welcome. Anyone else having trouble? This part is just telling you that you don't have to add or subtract the period. That's all that means. So your answer would just be exactly what I circled here.
21 is just the degree of the angle.
Yeah. It's the degree of this first angle. So 180 plus 41.8, right? And then the second angle would be 360, almost a full circle, minus the 41.8.
So there are two answers for this one.
So there's three answers. There's 90 degrees, which was pi over 2. So pi over 2 is one answer. And then 3.9 and then 5.6. I have it written out a little more neatly in the solutions for the review if it's hard to follow this, but it's pretty much the same work, just written a little smaller. All right, the second problem, we're looking to solve for x. So the way we solve for x is we get rid of, like, start from the outside and work our way in. We're going to get rid of this 3 first by dividing everything by 3. So we just get y divided by 3 is equal to sine of x divided by 2. To get rid of sine, we could take the inverse sine of both sides. Taking the inverse signs cancel out with taking the sine. And we're just left with inverse sine of y over 3 is equal to x divided by 2. But we don't want to know what x divided by 2 is. We want to know what just x is. So we can multiply everything by 2 to get rid of that dividing by 2. And we just wind up with x is equal to 2 times the inverse sine of y divided by 3. Anyone have any questions with this? All right, for this second problem, when we're talking about proving identities, I have like 4 or 5 supplemental worksheets on this. So if you want extra practice, you have my math lab, but they kind of guide you through it, I heard. So that's not the best way to practice. The best way to practice this is section 7.1 and 7.2. You should go to the supplemental materials folder and work on some of those worksheets. I do have all the solutions posted. The way that you really get better at that is by practicing. So we want to try to make the left side look like the right side. And we're not allowed to touch the right side, but just so we kind of have an idea what's going on, the right side is really just 4 times tangent times secant. So that's what we have to make the left side look like. This has to somehow turn into that. And in class, we went over 5 different types of examples. We saw a problem where if it was fractions, we had to get a common denominator. So for this problem, what I'm going to do, on the left side, it looks like the LCD is 1 minus sine times 1 plus sine. So what we're going to do is we're going to make sure that every denominator has that. So on the left here, I'm going to have to multiply by 1 plus sine over 1 plus sine to get a common denominator. And I'm going to multiply that by 1 plus sine over 1 minus sine. Minus the second fraction. But again, in order to get the same denominator, we're going to have to multiply by the factor that's missing, which was 1 minus sine. The reason why we do that is if you look at both fractions now, both denominators are exactly the same. So we can go ahead and combine those fractions. I'm going to combine the fractions, but I'm also going to distribute the top here. This will be 1 plus 2 sine theta plus sine squared of theta minus, distribute this, 1 times 1 is 1, minus 2 sine theta plus sine squared of theta. And that's what happens if we distribute here. All divided by the same denominator, which was 1 minus sine times 1 plus sine. So let's go ahead and finish this. I'm going to distribute this negative. I'm going to distribute the bottom. And we get 1 plus 2 sine theta plus sine squared of theta minus 1 plus 2 sine theta minus sine squared of theta all over the bottom, which is 1 minus sine theta plus sine theta minus sine squared of theta. A lot of writing, but once we get a common denominator, the problem starts like solving itself. All you have to do is distribute. These cancel. These cancel. These cancel. So what this turns into is 4 sine theta divided by 1 minus sine squared of theta. All right, now at this point, we have to try to think about what we're trying to get. You see how in the original, we're supposed to get tangent and secant? It looks like somehow we have to get cosine squared in the denominator. Well, if you practice these enough, you'll remember that sine squared plus cosine squared is 1 is a Pythagorean identity. So 1 minus sine squared is just cosine squared. So 4 sine theta divided by cosine squared just turns into 4 sine over cosine times 1 over cosine, which is exactly what we wanted. 4 tangent times secant. You do have to show all those steps. So I have to be able to follow your work to see how you start from the beginning to get to the end. By the way, I told you I give you certain formulas. So the last page of the review, you can see the formulas that I give you. All right, I told you I'd give you these formulas, and here they are. So you know exactly what the formula sheet looks like. This is also the formula sheet for the final exam. Okay, so you know exactly what you're going to get. All right, moving on to this next page. Problem number 3 looks like potentially a law of sines or a law of cosines problem. So we always set them up like this. So I like drawing it out so we have an idea of what we're working with, helps us just to get organized. All right, so now that we have that, it looks like we have one example or one angle. So if we could figure out what side B is, then we could have a full fraction to use law of sines. So what I would do at this point is, let's figure out what side B is. That's part of the law of cosines. So make sure your calculator's in degree mode. And the formula was b squared is equal to a squared plus c squared minus 2ac cosine of b. So just make sure you type this in correctly. 15.1 squared plus 19.2 squared minus 2. 15.1 times 19.2 times the cosine of 168.2. Let's type that in to figure out what b squared is. I'm getting b squared is 1164.2. But remember, we don't round that answer because then our answer is going to be off. What you do at this point is you just, on your calculator, you hit the square root button and do second negative, and that tells you 34.1.
I got one.
Try it again.
But I came up with 34.0.
You should get exactly 34.1. So try typing it in, you might have a digit off.
So after 6.6 or
So just hit the square root button. So don't clear anything, just hit second square root. And then hit the second negative button. And it's going to take the square root of the last answer that you just pulled. Yep. Jared, are you still getting 34.1?
I was looking at
Yeah, all right, you should get 34.1. And now at this point, we have a full fraction. We have a fraction made out of b's. So we have 34.1 over the sine of 168.2 is equal to 15.1 over the sine of a. So if we just cross multiply here, you get 34.1 times the sine of a is equal to 15.1 times the sine of 168.2. Make sure you close parentheses when you type in sine and divide that by 34.1. Getting 0.09, but we're not going to round that either. You have to take the inverse sine of both sides. And if you type inverse sine of second answer, I'm getting 5.2 degrees. Now, please make sure you guys are typing these in. It's a little tricky to type in, but I'd rather you do it now and get it correct, for the test. So A is 5.2 degrees. Side B is 34.1. And then angle C, we just do 180 minus those angles. So 180 degrees minus 5.2 and 168.2. I'm getting 6.6 degrees. One thing I just want to point out, you're probably not going to like me that much for this, but you want to make sure that you put these degree symbols. So remember the degree symbols. If you forget to put the degree symbol, I have to take off a half point, because if you're telling me an angle without a degree symbol, that means radians. So you want to make sure that you put that. Yes.
0.09.
So you hit second sign, inverse sign, and then second negative. So you're taking the inverse sign of the previous answer.
Radical, rad after,
Mm.
or it's just like for problem one.
What about problem one?
It was just one and negative third, so we need to put rad after that, so it's still that it's radical. Or is it?
So what you would do at this point is you would just type in inverse sign of negative 2/3. And that'll give you 41.8. And you have to draw that in the right quadrant where sign is negative.
So you don't need to put radical after it?
No, we don't need any kind of radicals there. We're not. Oh, I'm sorry, Courtney. I just didn't understand right away. If you don't write a symbol, it automatically means radians. If you mean degrees, you have to put a degree. So you're asking me if you have to put radians here. You don't have to, because if you don't put something there, it means radians. Any other questions so far? All right, not hearing any questions, we'll go to problem number 4A. It says if secant is 2, what's cosine? Well, you have to try to remember your properties. We know that secant is 1 over cosine, and cosine is 1 over secant. So if I know that secant is 2, then by using our properties, cosine would be 1 over 2. I mean, that one should be pretty good for everybody. For the second problem, I know on the review guide, I did something a little differently. I think there's an easier way to do it. So I'll show you the way that I'd recommend you do it. If cotangent is 3/4, so cotangent's positive 3/4. What quadrants would cotangent be positive? Thank you. So what we're going to do is we're going to draw triangles in 1 and 3 whose cotangent would be 3/4. Just remember, anytime you go left or down, that side is negative. So once we draw a triangle based on cotangent being positive 3/4, we could figure out the hypotenuse. So 3 squared plus 4 squared equals the hypotenuse squared. The hypotenuse is always positive. So it looks like the hypotenuse is 5. Question's asking you for sine. Well, sine would be opposite over hypotenuse, 4/5. Opposite over hypotenuse, and negative 4/5. think that's an easier way to do it than using the Pythagorean identity, which gave us the same answer. But I think this is a little bit easier. For problem number 5, it says find the exact value of cosine of 15 using a half angle identity. So I'm going to look at my half angle identity formulas, which I'm giving to you. It's just the last page on the test. And a half angle identity for cosine says that the cosine of an angle divided by 2 is equal to plus or minus the square root of 1 plus cosine over 2. So in order to use a half angle identity, half of what number is 15? 30, right? So this is going to be cosine of 30 divided by 2. Let me ask you a question. We're trying to figure out cosine of 15. Cosine of 15 is right here. Is cosine a positive, or is that going to be a positive or a negative answer? Positive. You're in quadrant 1, so it has to be positive. But we want to figure out cosine of 30. Remember, cosine of 30 was a special triangle. We had 30, 60, 90. So you have to remember the sides too. 30, 60, 90. Cosine of 30 was root 3 over 2. We're getting really, really close. The way that we finish this, remember, this is kind of like a really ugly fraction. You have a fraction inside of a fraction inside of a radical. So what we want to do is we want to multiply the top and bottom to what's going to make the bottom into a perfect radical. And if you multiply top and bottom by 2, what you wind up with is the square root of 2 plus root 3 all over the square root of 4, which simplifies to just be square root of 2 plus square root of 3 all over 2. That would be the final answer. So I'd just encourage you to go back in the notes and look at those kind of problems. We spent a whole class on that stuff. You guys okay? Can I keep going? Find the exact value of sine of 2 theta. If sine of 2 theta, sine of 2 theta is 2/5, theta is in quadrant 2. So that means we could go ahead and draw theta in quadrant 2. Sine is 2/5. So automatically I'm going to figure out our hypotenuse by doing x squared plus 2 squared equals 5 squared. X squared, 25 minus 4 is 21. So x would be plus or minus square root of 21. Anytime you go left, it's negative. So we have all the sides. We just have to reach for our formula sheet. And the formula sheet for sine of 2 theta says that it's 2 times the sine of theta cosine theta, which, looking at our triangle, sine of theta is 2/5. Cosine of theta is negative root 21 over 5. So we wind up with negative 4 root 21 over 25. So when we multiply fractions, we just go straight across. 2 times 2 is 4, and negative root 21. So 4 times negative root 21 is negative 4 root 21 over 5 times 5 is 25. All right, for number 7, remember what we said. We said that we use this inside piece to draw the triangle. So if secant is root 2, and all students take calculus, secant would be positive in what quadrants? Secant's the reciprocal of cosine. So what quadrants is cosine positive in? Cosine would be positive in 1 and 4. So what we're going to do is draw a triangle there. And secant is adjacent over hypotenuse, root 2 over 1 for both of those triangles. Now, to figure out that other side, we're going to do root 2 squared plus y squared equals 1 squared. 2 plus y squared equals 1. Y squared oh, sorry, I made a mistake. I drew it out like cosine, but secant, the root 2 would be over here. Sorry. Secant is hypotenuse over adjacent. So hypotenuse over adjacent, root 2 over 1. So yeah, 1 plus y squared is 2. Y squared would be 1, so y is just square root of 1 is plus or minus 1. Okay. And the question is, what's the tangent? Tangent would be opposite over hypotenuse. So it's either going to be 1 or negative 1 over 1. That's where that comes from. Yeah.
So it says up there a small angular quadrant.
Yeah, so then I guess we only have to worry about the top one, right?
And then for number 6, we just leave it like that. We don't like do inverse sign and then divide by 2.
Why would you do inverse sign?
Just to get rid of like the sign.
So it's asking you to find the exact value of sine of 2 theta. So I understand what you're saying. If I asked you to find the value of theta, you're right.
Okay.
But I'm asking you to find the value of sine of 2 theta. So you just do that. All right, good question. Thank you for catching this in quadrant 1. Thank you. All right, you guys doing okay? Looks like we have a couple more to go. For this next one, if we're in quadrant 1, I recognize this root 3 over 2. Remember we had 30, 60, 90 degree triangles. And we also had 45, 45, 90 triangles. We had 1, 1, and root 2. So for this kind of problem, let's think about what this actually means. What angle gives us a sine of root 3 over 2? Look at those triangles. Would it be sine of 30 gives us root 3 over 2? Sine of 60 is root 3 over 2, or sine of 45 is root 3 over 2? Which one is it? Sine of 60 is root 3 over 2. Minus, what angle gives us a cosine of root 3 over 2? 30, 60, or 45? 30. All right, so we're using what we understand about trigonometry to do this. 60 minus 30 is 30 degrees. And what's the tangent of 30 but opposite over adjacent? 1 over root 3. We can multiply by root 3 over itself to get root 3 over 3. That would be the answer. All right, and then these last few problems, you don't have to know how to do this one. You don't have to know how to do this one. You don't have to know how to do this one. Okay. The only ones you have to know are the ones that we focused on in class. So when we talked about sine, we said that sine, to get the principal value, so arc sine, we said that theta was between negative 90 and positive 90, which was similar to tangent, but we didn't include those because that had an asymptote there. So this will be multiple choice. You just circle the right one, okay? And cosine was between 0 and 180.